Scientists are working around the clock and racking their brains, striving to unlock the mysteries of the enigmatic celestial bodies hidden in the dark and frigid expanse beyond Neptune. These celestial entities are like secret messengers forgotten by time, carrying crucial clues about the early evolution of the solar system, waiting for us to decipher them. The so-called Kuiper Belt, situated beyond the orbit of Neptune, is a bone-chilling and dimly lit frontier region. It can be regarded as a natural deep freeze warehouse suspended at the edge of the solar system. Concealed within it are thousands upon thousands of primordial celestial bodies, forming a veritable mysterious cosmic museum. Astronomers, much like detectives, are devoting all their efforts to studying this poorly understood region beyond Neptune. They hope to piece together the grand narrative about the origin and evolution of the solar system, and even the existence of hidden planets, through these faint small celestial bodies. One of the greatest mysteries surrounding these trans-Neptunian objects is their birthplace, their astonishing abundance, and their incredibly elongated and mind-boggling elliptical orbital trajectories. What's even more exciting is that these anomalous orbits may hint at the existence of a yet-to-be-discovered ninth planet lurking in the dark corners of the solar system. We can envision the Kuiper Belt as a long-neglected cosmic treasure trove, filled with primordial materials left over from the early days of the solar system's birth, approximately 4.5 billion years ago. They have been preserved so intact that they are like samples from a time machine, awaiting scientists to decode the ancient cosmic cipher. In fact, these trans-Neptunian objects are likely much older than the oldest rocks on Earth and the earliest fossils. Having experienced hardly any intense geological activities or large-scale impacts, they are considered the most pristine and unadulterated remnants from the formation period of the solar system. These celestial bodies slumbering in the cold depths of space are primarily composed of various volatile substances such as rock, methane ice, and ammonia ice. In the extremely frigid environment of nearly -200 degrees Celsius, they have remained almost frozen for 4.5 billion years, with their appearance and internal structure barely changed. They are like frozen time capsules, quietly awaiting exploration by scientists. Interestingly, some experts in celestial dynamics speculate that these mysterious objects did not originally stay obediently in their positions within the Kuiper Belt. Instead, during the early days of the solar system, due to the violent migrations and gravitational interactions among the gas giants like Jupiter, Saturn, Uranus, and Neptune, they were flung into distant orbits. It's as if they were small balls in a giant billiard game, being redistributed to their current locations. Since that cosmic scale reshuffle, more than 100,000 small celestial bodies of various sizes have been orbiting the Sun aimlessly along all sorts of mind-boggling orbits in the frontier region beyond Neptune. Some of these orbits are so peculiar that scientists are still trying to figure out how they were formed. In the remote and almost desolate space beyond Neptune, the sunlight is so faint that it can barely penetrate. Even Pluto, which was once regarded as the ninth planet, can only glimmer feebly in this dimness. And further away, dwarf planets and tiny celestial objects drift alone in the bone-chilling cold and eternal darkness, as if caught in a silent cosmic winter. So, the question arises, why are scientists so obsessed with this icy and isolated corner? The answer is thought-provoking. These trans-Neptunian objects are like fossils left over from the birth of the solar system, preserving precious clues about planetary formation, the migration of the solar system, and even the evolution of the early environment. In a sense, understanding these tiny celestial bodies is like deciphering the oldest and most mysterious chapter of the history of our cosmic home. Trans-Neptunian objects not only offer us a glimpse into how planets gradually formed, but also may unveil the secrets hidden on the dark fringes of the solar system. For example, the ninth planet, which has not been directly observed yet, but is speculated to exist. If this hypothetical super-Earth planet does exist, it will completely rewrite our understanding of the structure of the solar system. Against this backdrop, a grand project named the Dark Energy Survey Day has inadvertently become an important milestone in the study of trans-Neptunian objects. The original mission of this survey was, between 2013 and 2019, to use the world's most advanced telescope system to explore the mysteries of the expansion of the universe and search for traces of dark energy. Scientists employed the giant observing equipment located on the high plateau of the Andes Mountains in Chile, collected data from hundreds of millions of galaxies, and mapped a detailed picture of the large-scale structure of the universe. However, while meticulously mapping the regions beyond the Milky Way, astronomers unexpectedly stumbled upon a hidden treasure within our own solar system. They discovered thousands upon thousands of trans-Neptunian objects that had never been recorded before. In total, the Dark Energy Survey identified 8,815 trans-Neptunian objects, among which 460 were brand new and previously undiscovered celestial bodies. These newfound discoveries have opened a brand new window into the world at the edge of our solar system. The secret behind this remarkable achievement lies in the fact that the imaging system of the Dark Energy Survey was designed to be extremely sensitive, capable of detecting the faint glows of distant galaxies in the almost pitch-black expanse. As a result, it was also perfectly suited to precisely capture the faint reflected light of those dim small trans-Neptunian objects. It's important to note that these trans-Neptunian objects are typically more than 250 times farther from the Sun than the Earth is, and some are even more distant. They travel slowly along orbits that can last hundreds to thousands of years, like wanderers on a timeline stretched to the limit. Even more remarkably, through in-depth analysis of this data, scientists have not only created a detailed map of the outer reaches of the solar system, but also uncovered the peculiar patterns of the distribution of trans-Neptunian objects. Some of their orbits cluster together in groups, while others exhibit strange tilts. This phenomenon further supports the speculation of the existence of the ninth planet, because only a hidden massive object could use its gravitational force to pull these objects into such abnormal formations. Further research also indicates that the complex gravitational interactions among trans-Neptunian objects may be a microcosm of the planetary formation mechanism in the early solar system. Hidden behind these seemingly chaotic and tiny orbits are the traces of the cosmic chaotic forces that were at play during the birth of the entire solar system. And it was precisely by utilizing this batch of data that astronomer Mike Brown carried out a revolutionary search for the existence of the ninth planet. Now, let's focus on some of the most fascinating and story-rich trans-Neptunian objects. First up is the asteroid 486,958, famously known as Arakoth. Its name, which means sky in the Powhatan language, was once known by the moniker Ultima Thule. It was first discovered by the Hubble Space Telescope in 2014, and later, on January 1, 2019, the New Horizons spacecraft made a close flyby of it, sending back stunning high-definition images. Arakoth is composed of two connected celestial bodies, forming a contact binary. Its shape closely resembles a twisted snowman or a potato spinning in the depths of space. This peculiar structure suggests that they gently merged together after a very low-speed collision, barely causing any damage to each other. Such a well-preserved state is truly a wonder in the history of celestial evolution. On its surface, the asteroid 486,958 has a faint reddish hue. This is because the organic molecules on its surface have undergone complex chemical reactions after being irradiated by cosmic rays for hundreds of millions of years. It is classified as a cold classical Kuiper Belt object, which means that its orbit has remained almost undisturbed since the formation of the solar system. This makes the asteroid 486,958 a natural time capsule, providing scientists with invaluable insights into the early stages of planetary formation. When it comes to the star celestial bodies in the Kuiper Belt, how can we not mention the dwarf planet Eris? Its discovery was not only that it is almost as large as Pluto, with a diameter of 2,326 kilometers, but it also directly triggered a major debate in the astronomical community about the definition of a planet. This ultimately led to the reclassification of Pluto in 2006 and the creation of the new category of dwarf planets. Eris has an extremely elongated and tilted orbit. When it is at its farthest distance from the Sun, it is much farther away than Pluto. Moreover, the angle of its orbit is completely different from that of the vast majority of planets, as if it were challenging the existing order of the solar system. Its surface is covered with a thick layer of frozen methane, which glimmers with an icy light under the faint illumination of the distant Sun, making it one of the brightest objects in the Kuiper Belt. In addition, Eris has a small moon named Dysnomia, which helps scientists more accurately measure the mass and density of this icy giant. In this mysterious cosmic wilderness of the Kuiper Belt, besides the asteroid 486,958 and Eris, there are many more peculiar celestial bodies waiting for us to explore. Take Haumea, for example. It is truly an anomaly in the universe. Haumea is approximately 1,960 kilometers wide. Although it is a bit smaller than Pluto, it has an incredibly exaggerated characteristic. It rotates frantically. It only takes about 4 hours for Haumea to complete one rotation, making it one of the fastest spinning large celestial bodies in the entire solar system. Thanks to this near-frantic rotation speed, Haumea has become incredibly flattened, resembling a giant rugby ball or a spinning water droplet. This defies astronomers' traditional understanding of the shapes of dwarf planets. Adding to the surprise, Haumea has a ring system around it. It's worth noting that, apart from the massive gas giants, very few celestial bodies in the solar system possess ring systems. These rings, likely remnants of a violent collision, spin rapidly around Haumea like a misty halo, serving as a reminder of the dramatic cosmic events that once took place here. Additionally, Haumea has 2 small moons, Haumea and Haumea, named after Hawaiian goddesses of fertility and the ocean, symbolizing the eternal struggle between creation and destruction. Their presence provides scientists with an excellent laboratory to study the gravitational complexities of a triple body system. Then there's Sedna, an enigma of the solar system's fringes. Discovered in 2003, Sedna is a solitary traveler. Even at its closest approach to the Sun, it remains 76 astronomical units away, and at its farthest, it drifts out to a staggering 937 astronomical units. It takes an astonishing 11,400 years to complete one orbit around the Sun. Its orbit is so peculiar that many scientists suspect it didn't form within the Kuiper Belt at all. Instead, it may have originated from an unknown region beyond the solar system, perhaps the theorized Oort cloud, which lies in the distant darkness. Some theories even suggest that Sedna could have been pulled into its current orbit during a gravitational interaction with a passing star or the hypothetical 9th planet. Sedna's reddish surface indicates a rich presence of organic molecules, the result of prolonged exposure to cosmic rays. The existence of these organic substances hints that, even in the coldest, darkest corners of the solar system, the chemical building blocks of life may have quietly formed. Kuiper is another remarkable discovery. Found in 2002, with a diameter of about 1,110 kilometers, it's a prime candidate for dwarf planet status. What makes it truly fascinating is its surface, which is covered not only with water ice, but also contains trace amounts of organic materials. This combination suggests that, in the dark outskirts of the solar system, the basic chemical components necessary for life had already come together. In 2007, scientists discovered Kuiper's small moon, Haumea. The gravitational dance between them has allowed astronomers to measure their mass and internal structure more accurately. In 2023, Kuiper once again stunned the scientific community with the discovery of an extremely rare ring system around it. Such a feature is almost unheard of among non-gas giant celestial bodies in the solar system, previously only seen around Saturn, Uranus, and Neptune. Kuiper's rings pose a significant question. How can a small celestial body maintain such a delicate and stable structure? This mystery, still unsolved, has prompted scientists to revisit and revise theories about the formation and evolution of Kuiper Belt objects. Next is Varuna, a name that exudes an air of mystery. Often referred to as the anti-Pluto, its orbit closely mirrors Pluto's, but in the opposite direction. With a diameter of around 910 kilometers, Varuna is one of the larger bodies in the Kuiper Belt. Its surface shows signs of water ice and possibly methane ice, offering valuable clues for understanding the evolution of materials in the outer reaches of the solar system. What's even more intriguing is the unique relationship between Varuna and its moon, Igerak. The two are relatively similar in size, leading scientists to speculate that they might form an unclassified binary dwarf planet system. This close companionship adds another layer of mystery to the Kuiper Belt. Finally, we come to the most anticipated topic, the 9th planet. Although it has yet to be directly observed, scientists are uncovering more and more hints of its existence. For instance, deep in the Kuiper Belt, the orbits of many large trans-Neptunian objects are anomalously curved, and their perihelions the points closest to the Sun seem to converge in a specific direction. Statistically, this pattern is highly unlikely to occur by chance. The most plausible explanation is the presence of a massive celestial body far beyond, whose powerful gravitational pull gradually takes these objects' orbits into alignment. Models predict that the ninth planet could be a super-Earth, with a mass 5 to 10 times that of Earth, and an incredibly long orbital period, possibly taking over 10,000 years to complete one revolution around the Sun. If it exists, at its farthest point from the Sun, it could be hundreds or even thousands of astronomical units away, nearly 20 to 30 times the distance of Pluto. Its discovery would not only revolutionize our understanding of the solar system's structure, but also unlock secrets about the early days of the solar system, such as whether the Sun ever stole foreign objects from star clusters. As telescope technology continues to advance, especially with the advent of ambitious projects like the Vera C. Rubin Observatory, we may soon find direct evidence of the ninth planet and finally lay eyes on this mysterious giant lurking at the edge of the solar system's darkness. In the vast, frigid expanse beyond Neptune, celestial bodies float silently, as if time has lost its meaning and history has solidified into cold fragments. Each tiny rock, each solitary spinning object, is like a page of secret notes written on the edge of the cosmos, waiting for humanity to read and understand. Perhaps these distant, glimmering worlds hold the most pristine memories of the solar system's birth. Maybe the ninth planet watches us from the shadows, a silent observer of the solar system's eons-long journey through the universe. In our quest to understand these frozen relics, we are, in a way, searching for our own origins, the spark of that first human gaze at the stars, the mystery of life's emergence from chaos, and the significance of our small yet tenacious existence in the vast cosmos. The world beyond Neptune may not offer quick answers, but it teaches us that true exploration isn't about reaching a destination. It's about conversing with the unknown and walking hand in hand with mystery. Thank you for watching. Stay tuned for more films on cutting-edge science and technology.